Hello, welcome to this YouTube channel. This YouTube channel is actually, for students who are preparing for IBDP biology, be it the May June IBDP biology or the October November IBDP biology. So this YouTube channel is actually to assist students, who are struggling with biology, IBDP biology. If you're struggling with IBDP biology, or you want to just, get ahead in biology, this YouTube channel is for you. And a bit of introduction about myself. So my name is Mr. B, and I have years of experience teaching IB biology. I thought of reaching a larger audience. That's why I actually created this YouTube channel to help students, who are struggling in biology, you know, to demystify that idea that biology is a hard subject. So I'm going to be helping you, understand the concepts, how to approach the exam questions, the IB biology past papers. I'm going to help you with some exam style question at the end of each video. So if you are struggling with biology or you want to improve your IBDP biology, you're in the right channel. So let's get to what we have to do. Today we are looking at water, which is the first topic of the current IBDP biology. All right, and what are the learning objective? We're going to be looking at the importance of hydrogen bond between water, the cohesion of water molecule and its importance, the adhesion of water and its importance, okay, and the physical properties of water. Then we'll look at the HL content. Okay, now water has a medium for life. So water is essential for many of the activities we do every day. We use water for bathing, for laundry. Think of it, water is a medium for life. So in living organism also, you know, water is used for many of the activities within the cells. So it is believed that water is a medium for life, and it is believed that life was evolved in water. So it is believed that all living things are dependent on water. So water is a medium for life. All right. So water serves so many purposes in living organism for many of the metabolic reaction that happens within and outside of the cell. Okay, many cell communications happen using water medium or aqueous medium. Now let's go on. The next one is the hydrogen bond, which is as a consequences of polar covalent bonds. So hydrogen bond, now before we will look at hydrogen bond, we need to understand the structure of water. Okay, so we need to understand the structure of water. So I'm going to be taking into the structure of water. Water chemical formula is H2O. So the chemical formula of water is H2O. So water has two hydrogen bonded to one oxygen. So you have something that looks like this. So you have oxygen and two hydrogen. Okay. So you have oxygen and two hydrogen, something like this. So this is the chemical formula of water, and this is the structure of water. So water has two hydrogen bonding to one oxygen, and this you know hydrogen bond is responsible for many of the properties of water, which we are going to be looking at in the following section. So hydrogen bond is as a result of polar covalent bond. So what is a polar covalent bond? A polar covalent bond involve unequal sharing of electron. Now what do I mean by that? Now this is a bit of chemistry, but I'll try and make it as simple as possible. So in polar covalent bond, there is electron sharing, okay, between two atoms of different electronegativity. Now between this oxygen and this hydrogen, there is a sharing of electron. Oxygen is more electronegative. Now by the word electronegative, we mean that is the ability of an atom to draw electron towards itself. So think of oxygen is more electronegative. That means oxygen draws more electron or attracts more electron towards itself, while hydrogen is partially positive. Okay, the two hydrogen is partially positive. So more electron is drawn towards the oxygen than to the hydrogen. So in water, we say that a polar covalent bond exists within a water molecule. I use the word within. So within this water, between this oxygen and hydrogen, there is a polar covalent bond existing there. Okay, so a polar covalent bond exists within the oxygen and the hydrogen atom. Okay, take note of that. So a polar covalent bond involve unequal sharing, and this unequal sharing, like I said, is due to electronegativities. And you know, like I said, this is a bit of chemistry, but what you need to focus on is the fact that um, there is unequal sharing of electron between oxygen and hydrogen, and so more electron is drawn towards the oxygen, okay, than the hydrogen, okay, and this, you know, results in um, hydrogen bond. Now, hydrogen bond, on the other hand, is found between one water molecule and another water molecule. So I'm going to be illustrating that as well. So hydrogen bond is found between one water molecule. So this is one water molecule, okay, and this is another water molecule. Okay, this is another water molecule. So this is another water molecule. Yeah. Now between this water molecule, the hydrogen bond exists between the oxygen and the hydrogen. So this is the hydrogen bond illustrated here. This is the hydrogen bond. So hydrogen bond exists between the oxygen and hydrogen. Alright, so this is one water molecule, this is another water molecule, and this is the hydrogen bond, joining them together. So hydrogen bond exists between one water molecule and another water molecule and is responsible for many of the properties of water. Alright, so we go to the next section, which is still talking about hydrogen bond. So hydrogen bond are intermolecular force that exists between water molecule, like I explained in the previous slide, and hydrogen bond are formed as a result of polarity. I also explained, polar covalent bond. So hydrogen bond are formed as a result of polarity. So I've actually explained that. And again, for the sake of emphasis, so this is one water molecule. So between this water molecule and the next one, there's an hydrogen bond. Okay, and also there's an hydrogen bond here, and within here you have a covalent bond. All right, let's go on to the next slide, which talks about cohesion of water molecule due to hydrogen bond. Now, these are the effects of this hydrogen bond, and one of them is in cohesion. So cohesion is the ability of a substance or a particle to stick together. So cohesion is just like, I think I like to use this word, likes plus like. Okay, that's cohesion. So water is attracted to another water molecule. So when water molecule is attracted, so that is the force of cohesion. So cohesion is the ability of a substance to stick, and water is said to be cohesive. So water is able to stick to each other. Okay, water molecule is said to be attracted to each other. So water molecule is said to be attracted to each other. All right, and this has effect in the upward movement of water from the roots to the leaves. All right, so water is able to move from the roots to the leaves using cohesion. So water is, move from the roots to the leaves using cohesion, and this allow transport of water, okay, under tension in plants. So this illustration shows cohesion. So cohesion is water to water. Okay, cohesion is, water is attracted to each other in cohesion. We're going to talk about adhesion, in the subsequent unit. So understand that the effect of cohesion is that it allows, or the application of cohesion is that it allows water to move upward roots to the leaves. All right, let's go on to the next one, which is the use of water as surface tension due to as habitat rather due to surface tension. So water is used as a habitat for many organisms, and you know one of the properties that make water to serve as a habitat is due to its surface tension. And so, what is surface tension? It's a tendency of a liquid to resist external force, and this is due to the cohesive force. So, surface tension allow water to be like a stretch, elastic film. So, it allows water to appear like a stretch elastic film, and this property is used by organisms such as water striders, small insects that are able to skate on water, and this is due to surface tension of water. So water has a high surface tension, and this you know makes it possible for organisms like water strider to skate on water. So this is what surface tension looks like in this image, and you can see this sponge skater, okay, on this water, and look at it. This is how the surface tension looks like on water. I'm sure you must have seen this before. And also this is another one here. These are paper clips floating on water due to surface tension. All right, so take note of that as well as we proceed. Now, the next one is the addition of water. And if you remember when I was discussing cohesion, there was an image that shows cohesion and adhesion. So this is addition of water. Addition is just water to other molecule. So we are now looking at the adhesion of water. So addition is the ability of a substance to stick to unlike substances, okay, or attract, unlike particles. So addition is between, again, I will use like here. So I will just say like plus unlike, or we say like plus, okay. So this is like plus unlike. So water is attracted to, you know, other substances. So that is the case of adhesion. So water is adhesive. Water is able to stick to other polar or charge molecules, okay, via the formation of polar association. So water is attracted to the cell wall of plants, okay. Water is attracted to the cell wall of plants. So I'm going to use an illustration. This is just me trying to illustrate a plant. This is a plant, for instance, and this is a plant, and this is, you know, a plant, and water is moved up from the roots to the leaves using the force of cohesion, like I mentioned earlier, and the force of adhesion, that is, water is attracted to the cell wall of the plant. Okay, water is attracted to the cell wall of the plant. So both force of cohesion, the cohesion and the adhesion, plays a role in the movement of water from the roots to the leaves. So cohesion allows water to stick together, okay, and adhesion, allow the movement of water to stick to other particles, okay. So in plants, for instance, one of the application or one of the yes application of cohesion is the movement of water from the root to the leaf. So water is attracted to polar substances like the cell wall of plants, and these allow water to be moved up against gravitational force. So water is moving up against the force of gravity. So the water is moving up against the force of gravity, okay, in a process called capillary reaction. So water is moving up against the force of gravity in a process known as what? So as water is moving up, okay, it is moving up against the force of gravity in a process known as a capillary action. All right. So think of capillary action as when you draw, like when you use a straw to draw water. Okay, when you draw water or draw any liquid particles with your straw into your mouth, the same way it happens in capillary action. All right, so I'll be going on to the next slide, which is still talking about the effect of capillary reaction. I think I've explained that already. So I'll be going to other properties of water, which talks about the solvent properties of water, and water serving as a solvent. So water is a solvent for many of um, the substances. So it's a solvent that dissolve other substances. Now, a solvent is a substance that is able to dissolve a solute. So a solvent is able to dissolve a solute, and um, water is said to be a universal solvent. Though water cannot dissolve all substances, but is generally regarded as a universal solvent. Right. Now, substances that are attracted to water are said to be hydrophilic. I thought I should mention that. So substances that are attracted to water are said to be, an example of such include glucose. Okay. Polar substances are said to be able to dissolve in water, so they are said to be hydrophilic. All right. So all substances that are attracted to water are said to be hydrophilic. So hydrophilic substances are attracted to water. And I also thought I should mention again that not all hydrophilic substances are can dissolve in water. Not all hydrophilic substances can dissolve in water. But the key word here is that hydrophilic substances are substances that are attracted to water. All right. On the other hand, hydrophobic substances are not attracted to water. So we have hydrophilic rather, and we also have hydrophobic, and we also have these are water loving. Okay, water loving. Then you also have hydrophobic, which are water repellent or water heating. So hydrophobic, on the other hand, they are water heating. Hydrophobic are water heating. So hydrophobic are not attracted to water. Okay, so hydrophobic are not attracted um to water. Okay, I thought I should mention that. All right, let's go on to the next one. As we also look at the solvent properties as linked to metabolism. Okay, so the capacity of water to dissolve a large variety of substances makes it an excellent medium for metabolic reactions. So, like I mentioned at the beginning of this topic, that water is used for many of the metabolic processes that happen within the cells and outside of the cell. So, water serves as a metabolic, serve metabolic properties in cells. Okay, and these reactions are catalyzed by enzymes, which is also a topic we'll be looking at in this course. Another properties of water linked to solvent properties is the transport medium. Earlier, when I was explaining the movement of water from the roots to the leaves, when I was explaining how water moves from the roots to the leaves, using the force of cohesion and adhesion. Okay, if you remember, we said water is moved from the root to the leaves. Now, this is a transport property of water. So while water is moving from the root to the leaves, it transports substances, okay, from the root to the leaves of plant, and even in animal, you know, the blood cells, the blood plasma rather, the blood plasma transports solutes. So the blood plasma contains many solutes which are transported from one part of the body to the other. And this blood plasma contains water. So water is used as a medium of transport in living organism. All right. So these are some of the properties of water linked to its solvent properties. All right. Now let's look at the physical properties of water. And this first one we're looking at is buoyancy. Okay, buoyancy is the upward force to an object. So think of buoyancy as a force that moves, okay, that pulls an object up. So is an upward force on to an object in a medium, and water is said to be buoyant. So buoyancy depends on the density of the fluid and the density of the object. Okay, so buoyancy in simple term is the ability of an object to float in the fluid. Okay, so water is more dense. Okay, water is more dense than air, and so water tend to have more is meant to be more buoyant than air. So that's why you see object floating, you know, in water. All right, so this is one of the first physical properties of water. The second one is viscosity. So viscosity is a measure of the tendency of a fluid to resist flow. That's viscosity. So water is said to be viscous. So um different liquid have different viscosity. Like the example in this scenario is we are using honey, oil, and water. Now, of course, honey has is more viscous than oil. So, but water has more viscosity than hair. We are going to be comparing the properties of water with that of hair. Okay, so we are going to be focusing on water and hair here. We're going to be looking at the physical properties of water with the physical properties of hair. So, viscosity is a tendency of a substance to resist flow. All right. So, water is more viscous than hair. All right, and this viscosity is due to hydrogen bond. All right, I'll go on to the next properties of water, which is the specific heat capacity. Okay, the specific capacity is described as the amount of energy required to raise 1 gram of substance by 1 degree Celsius. And water has a high specific capacity, and this is due to the hydrogen bond. These are the consequences of the hydrogen bond I mentioned earlier. Hydrogen bond has so many effects on water. Many of the properties of water are due to hydrogen bond. All right. So, and this specific capacity is one of the reasons why water temperature remains stable. Even when the water and the when the environment is hot or cold. So water temperature does not change easily, and this is due to the specific capacity of water. So water is able to maintain a relatively stable temperature as a result of the specific heat capacity. All right. Now another properties of water is the physical property, and is the thermal conductivity. Rather, thermal conductivity is a measure of a substance or of the medium to move heat, so to be able to conduct heat, and water is able to transfer heat readily than air. Okay, so water has a high thermal conductivity compared to air. And this table will be looking at the comparison between water and air. So this table summarizes everything we have been discussing so far under the physical properties of water. Buoyancy: air is less dense than water. Water is more dense than. And what are the consequences for you know living organisms? So we'll be looking at two organisms here, and we'll be comparing the ring seal and the black-throated. So we'll be comparing these two organisms, okay, to look at the effect of these physical properties of water, in their habitat. So the black-throated is able to fly through the air using more energy because, of course, they experience little resistance in the air, okay, because air is less dense than water. For the ring seal is able to float. The ring seal is able to float due to the presence of blubber. Okay, they are able to float due to the presence of blubber. So these help them to be buoyant in water and not sink. Okay, so they have a blubber that helps them to be able to float in water. Then the viscosity here is less viscous than water, and water has a higher viscosity compared to air. So what is the consequence for these two organisms? The black-throated experience less resistance through the air, okay, because air is less viscous. And for the ring seal, it experiences more resistance, okay, so it actually exerts more energy to move through water because water is more viscous than air. Then the other one is thermal conductivity. Air has a lower thermal conductivity to water. And so what is the consequence for these two organisms? The black-throated seal is able to the black-throated rather is able to maintain its body temperature above their environment, okay? And the ring seal may experience difficulty, keeping their body constant. So these are the, effects of these physical properties of water. And lastly, we'll be looking at, just to summarize everything we've been discussing so far. So we've looked at water, and we have looked at the physical property. So we looked at the bond within water. We said covalent bond is found within water, and between water we have hydrogen bond between one water molecule. And we look at the effects of this hydrogen bond. One of them is cohesion, adhesion, and solvent properties. We look at the transport properties of water and surface tension. Please take note of that. Then we also look at the physical properties of water here, which include specific capacity, buoyancy, thermal conductivity, and viscosity. So this is what we have learned in this um, unit. So I will just go through some, before we go to the HL content, which will be in our next video. I will just go through some practice paper, in next few minutes. So some practice paper on water. So let's look at this together. So what allows the movement of water under tension in water? So what allows the movement of water under tension in the xylem rather? So addition of water, no, we said that is not the reason why. Okay, we said there are two forces that are involved. Water is moved using force of addition and cohesion, right? But this is under tension in the xylem, and if you remember, we talked about cohesion. All right, so and that will be B, because water move in the xylem, under tension in the xylem, using hydrogen bond, due to hydrogen bond. So it's not force of cohesion, it's not force of addition rather. And this other one, which is option D, is cohesion between water molecule. So cohesion does not happen between water molecule and polar, is between water and water. So the answer is B. Okay, so what is the properties of water? Water has a low specific capacity. No, water has a high specific capacity. Water is an excellent solvent for non-polar. No, water is an excellent solvent for polar substances. All right. Covalent bond between adjacent water are responsible for its unique properties. So covalent bond is not found between. So usually to understand the keyword is found within. So that's not the correct answer. The water molecules are highly cohesive, which is important for. Okay, so take note of how you answer these questions on water. Look for the keyword. All right, this is what the exams. Another question says, water linked by hydrogen bond, oxygen, hydrogen and oxygen within water molecule. Now I said in this video that hydrogen bond exists between the hydrogen, okay, and the oxygen of one water molecule and another water molecule. So if you look at, so I remember, let me just, for the sake of explaining it better again. So you have something like this. So hydrogen and oxygen. So if you look at this, so the hydrogen bond is found here. So this is between one water molecule and another water molecule. So this is the hydrogen bond. So it is not within. Okay. So it is option D, that is between different water molecules. So I hope you understand how the answers, how I actually arrive at the answer. Okay, I'll be doing this also. The diagram shows water molecule. Which property is not illustrated? Which property is not illustrated in this? So this is showing a hydrogen bond. This is showing hydrogen bond, like I illustrated. So hydrogen bond has effects on cohesion, if you remember. Hydrogen bond is also is illustrated here. Okay, and also we also have dipolarity. Hydrogen bond is also is shown here. There is dipolarity here, but it is not illustrating adhesion. So it is not illustrating adhesion. All right. So so there are questions, for us to do. Many questions. Another question here says that what is correctly annotated in the which is correctly annotated in this diagram, and that would be, so if you remember, I showed you that oxygen is delta negative as partially negative, and the only option that shows that is option B. All right. Okay, I think I will stop here. We'll stop here today, and we'll continue for ADHL content in our next class. Thank you all for joining. See you in the next video.